As an odd flex, we are simply going to do the opposite of what we did in the previous video. In the previous video, we took expanded multiple logs and condensed it into one. Now we are going to take a condensed version and expand it. And the simple reason is sometimes we have to do this, and at this point you don't know when you're going to have to. But right now we just want to practice to see if we understand the rules. So this argument has a product. Things are multiplying. So we can write this as log base 3 plus another log base 3. And we can write the x as one of the arguments and the y squared as another. If we want to expand it a little bit more, we can use the power property and take this exponent of 2 and write it as a coefficient. So we could write this as log base 3 of x plus 2 log base 3 of y. Number 2, we could write this as natural log of x plus natural log of y to the 1/2. It's the same thing as a square root. It's plus because we were multiplying these. We can then take this exponent of 1/2 and write it as a coefficient. We are only doing this because the directions say write it in expanded form. That's what we're doing. We're expanding it. Number 3, since we are dividing in our argument, we're going to take the numerator argument minus log base 2 of the denominator's argument. And we can take the exponents of the arguments and write them as coefficients, because that is what the power property says we can do. Number 4, see if I can do this all in one step. Hopefully it doesn't confuse you too much. We have multiple things in the numerator, and we have c squared in the denominator. So we can write this as natural log of a plus natural log of b. That covers these being multiplied. Subtract natural log of c squared, and I can put the 2 in front so that I'm not writing this 2 as an exponent because I'm trying to expand it, trying to make it as big as possible. Number 5, it's going to be natural log of x plus 2, because that is the numerator, minus 2 times natural log of x. This would be natural log of x squared, but I'm going to write the 2 as a coefficient to expand it. Number 6, we could write this as log of 2, log base 2 of 2, plus log base 2 of a, plus log base 2 of c. All these are pluses, and they're all separate logs because the numerator in the argument has 3 things we're multiplying, 2, an a, and a c. Then we could subtract from this 1/2 log base 2 of d, because we would be subtracting log base 2 of d to the 1/2, or the square root, and you can take the exponent and write it as a coefficient whenever you want. And right now we want. One other thing that I could do here is log base 2 of 2 is asking 2 to what exponent is 2? Well, that is 1. So I could change that to 1 and leave the rest of these fulls the same. Last one. We could write this as common log, let me rephrase that, 3 times common log of x, that covers log of the x cubed, minus common log of y, minus common log of z. Both common log of y and z get subtraction because they're on the denominator of the argument. All right, that concludes this exercise. That's all this is an exercise to see if we understand how to use these different properties when we're supposed to expand or if we're supposed to condense. This is video 3 of 4. We got one more to do, kidders.